Our focus is the conversions between degrees and radian. So we have the degrees to radian, conversion of degrees to radian. We have also the radian to degrees. Now the technique in here is you have to know your multiplier. Okay, so multiplier. So when we have the conversion that is degrees to radians, our multiplier in here is actually pi over 180. So this is our multiplier, pi over 180 degrees. Okay, so that would be our multiplier when we are converting degrees to radian. And what about your multiplier when you have radian to degrees? You just reverse the pi over 180 degrees to 180 degrees over pi. Our pi in here has actually the unit that is rad. Okay, pi rad. Okay, or you can remove the word rad. Okay, so that is, or these are the multipliers that we have. So how do we multiply? Let's try to have. If our example is, shall we say, we have in here number 1. Okay, we will be converting 135 degrees. Okay, 135 degrees to radian. Okay, so radian. How do we convert this one? We just say 135 degrees multiplied by, that is pi rad over 180 degrees. Okay, 180 degrees. Notice that when we are going to cancel out units, the units degree will cancel out. Okay, the unit degree will cancel out. And so notice that when we are going now to divide this one, 135 over 180, we can just reduce by saying that that is the same as 3 pi. Okay, 3 pi over, or 3 pi rad over 4. Okay, 3 pi rad over 4, or we just say 3 pi over 4. When there is the presence of the number pi, meaning to say we are dealing with, or our number is in radian. Okay, so it's not a need to put the word rad. Okay, another one is we have in here number 2 example. We have in here 540 degrees. Convert it into radian. Okay, rad. How do we convert this one? Same procedure. We say 540 degree. Okay, dig multiplied by, that is the same as pi rad, okay, over 180 dig. Now for the sake of cancellation, I will be putting the dig. Now notice that when I'm going to do this one, this will always cancel out. And so what will remain is, if you notice, if we are going to have this one divide 540 divided by 80, it will give you, that is the same as 3 pi, or 3 pi rad. Okay, 3 pi rad. Okay, now what about if the number or the degree is negative. So shall we say number 3 example? Number 3 example, we say negative 270 degrees. Okay, we will convert this one into, again, radian. Okay, so how do we do that one? Same procedure. We say negative 270 dig, okay, multiplied by, that is the same as pi rad over 180 dig or degrees. Okay, now notice that the degree will cancel out. Okay, it will cancel out, and so that when we are going to reduce this one, negative 270 and 180, it will give you a result that is the same as negative 3 pi. Negative 3 pi over 2. So that is it. That is how to convert degrees to radian. So ayan, this is our final result. 3 pi, negative 3 pi over 2, and 3 pi over 4. Okay, I hope you had the idea of converting this one. Okay, now another one is, what about if we are going to reverse the conversion, shall we say radian to degrees? Now of course we can always elaborate this one by making example. Okay, so radian, our focus is radian to degrees. So shall we say we have in here negative pi rad, for the sake of making cancellation, pi rad over 2. Okay, over 2, and this will be converted to degrees. Yeah, degrees. So how do we do that one? Same method. We just reverse our multiplier. So if we have this one, a negative pi rad over 2, our multiplier would be what? 180 degrees to pi rad. Okay, so ayan, notice that pi rad can be cancelled out. And so what remains now is negative multiplied by 180. So that is negative 180 divided by 2. And so your final result must be negative 90 degrees. Yeah, negative 90 degrees. The final result is negative 90 degrees. I hope you got the point how to convert. Now let's say we have another one. Okay, we have another one. So that is, we have 9 pi rad over 2. 9 pi rad over 2. So what we will do is convert it into degrees. So degrees. Now how do we convert that one? Same procedure. You copy the given. What is the given? 9 pi rad over 2. Next, multiplied by what? Our multiplier is 180 degrees over pi rad, okay, over pi rad. Again, the rad in here is it's not a need to write it down, but for the purpose of this discussion and cancellation, I'm trying to put it in here, okay? So pi rad, pi, and then rad, pi, and then rad will cancel out, okay? So that is the same as what remain is 9 multiplied by 180 degrees, then divided by 2. So 9 divided by 2. And so the result is the same as, okay, the same as 810 degrees, okay, 810 degrees, okay. So that is the final result, okay. I hope you understand how to convert. Now what about this one? A very simple one, okay, a very simple one. So my very simple problem is we have in here 2 rad, okay, 2 rad, okay. So we have in here 2 pi rad, okay, and then we'll convert it into degrees, okay. So that is the same as in degrees. Yeah, so let's try to do it. Copy the given, 2 pi rad. What is your multiplier? Your multiplier is 180 degrees, okay, divided by pi rad, okay, divided by pi rad. So we have in here divided by pi rad. Okay, let's try to have. Notice that in here pi rad can be cancelled out. What remains now is 2 multiplied by 180. So the final result, what is the final result? That is the same as 360 degrees. So we have in here 360 degrees. You will notice that this is 1 revolution. So I hope that you understand how to convert radian to degrees, and then degrees to radian. What is the technique? Your multiplier. When you're converting degrees to radian, your multiplier is pi rad over 180 degrees. If that is radian to degrees, your multiplier is 180 degrees over pi rad. So thank you. Our focus is finding the length of an arc, or arc length, okay. So how do we find the arc length or length of an arc? The arc, remember the arc we are talking in here is a part of the circumference of a circle, okay. So to get or to compute for the arc length, now S will always be considered in here as the length, okay, length of the arc. So our S is considered to be the length of an arc. Now what about the R in here? The R in here is the radius of the circle, and the symbol theta. The symbol theta in here is actually the measure of the central angle, okay, central angle, central angle. Now this central angle is represented or in the form of radian. Okay, it is in the form of radian. Okay, so for the arc length, for a circle of radius r, a central angle theta intercept an arc of length s given by this equation, s equal to the product of radius and theta, wherein again the angle theta is measured in terms of radian. Okay, now note that if the radius is equal to 1, we consider the length of the arc is equal to angle theta. Okay, and the radian measure of theta is equal or equals the arc length. Okay, equals the arc length. Now to elaborate this one, we might as well give an example. Okay, give an example. A circle, what if a circle has a radius of 4? Okay, a circle with a radius of 4, shall we say centimeter. Okay, shall we say centimeter. Now the central angle is equal to 240 degrees. 240 degrees. Now our problem now is to look for the value, the arc length. Okay, the arc length. Okay, how long is the arc length? Or that is actually the S. Okay, that is actually the S. So how long is the arc length or S? Now how do we solve this problem? How do we solve this problem? Because we have said last time, or we have said a while back, that the angle theta in here is measured in radian. So first thing that you will be doing is you convert. Okay, convert the central angle. Okay, because the central angle is given in degrees. So where will you convert? Convert this one into radian. Okay, convert into rad or radian. So let's convert. So step number 1 is 200. So 240 degrees is to be multiplied by what? Pi rad. Okay, pi rad over 180 degrees. Okay, result, you notice that in here degrees will cancel out. So that is how to do it. Now after that one, we reduce this one. So when we reduce, the result will always be 4 pi rad. 4 pi rad over 3. So meaning to say, the measure now of the angle theta, or our angle theta now, has a measure of 4 pi rad over 3. Okay, over 3. Now after that, we can now solve for the arc length, which is represented by the S. So arc length, which is represented by the S. And so what is S? S again in here is R multiplied by multiplied by angle theta, or the central angle 240, which is reduced to radian. Okay, so how is that? S now is equal to 4, which is 4 centimeter, the radius of the circle. So 4 centimeter, okay, 4 centimeter, and then multiplied by what? Multiplied by the value of angle theta, that is the same as 4 pi over 3, okay, 4 pi over 3. And so if you multiply this one, if you multiply, it will give you now that is the same as 4 multiplied by 4. It will give you 16 centimeter pi divided by 3. So when we divide, it will give you now that is the same as 16.76 centimeter. Okay, so that is the arc, that is the arc length. Okay, so if you will notice, we can also draw this one. Okay, if we are going to illustrate, we can draw the circle. So the circle that we have is, we have in here, if this is the Pythagorean theorem, that is the angle theta is actually, or the circle is, shall we say, we have in here a circle. Bear with me with my circle. So that is my circle. Now the angle theta, which is the same as 240 degrees, is we have in here, coming from the this term initial side, going down in here. Okay, so most probably this must be the approximated, what is that? Approximated terminal side. So our initial side is this one, our terminal side is this one. Now notice that the radius that we have in here is actually r is equal to 4. Okay, this is 4 centimeter. Okay, 4 centimeter. Now what about this angle? The measure of this angle is 240 degrees. Okay, now where is the S that we are talking? Our S will be coming from this one. Okay, so the arc, intercepted arc, is this. Okay, this part, this side of the circle. Okay, so this one. So this is the arc length that we are talking. And so what is the measure of this one? The measure of the arc length now, is the computed 16.76 centimeter. Okay, I hope you understand the computation of the arc length. Thank you.